Okay, so your first question for this problem set was total travel time is 39 microseconds. How far away is the reflector? So the first thing you're going to ask yourself is, are they asking me for an answer in time or an answer in distance? So how far away is the reflector? They're asking me for an answer in distance. Okay, and are they giving me the total travel time, or are they giving me just a one-way travel time? And so it says total travel time is 39 microseconds. So we know that the total travel time is 39 microseconds. So I like to picture these as like an actual ultrasound screen, okay? So your total travel time is 39 microseconds. And we know that the rule is that for every 1 centimeter, you go 13 microseconds for a round trip time, down and back. And we're looking for round trip time. So 13 microseconds to get 1 centimeter, 13 microseconds to get another centimeter, 13 microseconds to get a third centimeter. So we went 13, this would be 26, this would be 39, and we know that our distance that we went total is 3 centimeters. Okay. The next question is asking you the same thing, but with different numbers. Total travel time is 13 microseconds. How far away is the reflector? So our answer will be distance, and they're giving us round trip. And this is an easy one because it's actually just our rule, which is that for every 1 centimeter deep I go, down and back is 13 microseconds. So if I'm going 13 microseconds, I only traveled 1 centimeter. Number 3 is that it travels for 13 microseconds before hitting a transducer. How far away is the reflector? My answer is still going to be distance. How far away is the reflector? But here it's a little trickier because it's not round trip time. Travels for 13 microseconds before hitting a transducer. It's only one way. So that should be a red flag, one way. So we have to do something a little different with one way. So if it takes 13 microseconds to get to and from a 1 centimeter structure, it only takes 6.5 to get to it. So we're only going to it. So 6.5 to get 1 centimeter. And then we go down to 2 centimeters. It's another 6.5, which gives me 13 microseconds. So it travels for 13 microseconds and gets 2 centimeters deep because we don't care about it coming back. So 6.5 down, 6.5 down gets us to 2 centimeters deep. Next question's asking us the same thing with different numbers again. This one feels trickier because it has the 19.5, but it's really the same thing. So it travels for 19.5 microseconds before hitting a reflector. How far away is the reflector? Answer in distance. And it's giving us a one-way time of 19.5 microseconds. So our 13 microsecond rule changes a little bit here, right? Because we're not going round trip anymore. So we're doing that 6.5 again. 6.5 gets us to 1 centimeter. Another 6.5 gets us to 2 centimeters, which now we're at a total of 13 microseconds. So we need to go further. Another 6.5 gets us to 3 centimeters, which then is 19.5 microseconds. And that's what they asked us to get down to go 6.5, 6.5, 6.5, which is 19.5 total. We would be as deep as 3 centimeters for our structure. We don't care about returning, so we're using that 6.5 number to figure out how far deep we get when we travel for 19.5 microseconds before we hit a reflector. Then these ones mix it up on you and they change what you're looking for. So reflector is 20 millimeters away. How long for the sound to get to the reflector and return to the transducer? So now we want to know time as our answer. And they're giving us a distance. And they, in this question, want to know round trip time. right? Which we like round trip because it's easiest. It's our 13 microsecond rule. So we think about our screen. 20 millimeters is the same as 2 centimeters. So I'm going 2 centimeters deep. And how long does it take me to get there and back to the transducer? Well, it takes me 13 microseconds to go round trip 1 centimeter, and it takes me another 13 microseconds to go round trip for the second centimeter. So together, that's 26 microseconds that it takes me to go round trip all the way down to 2 centimeters and all the way back to the transducer. So same thing here, where we're looking for round trip time as our answer. Our reflector is 30 millimeters away. So how long does it take for sound to get to the reflector and return to the transducer? So let's see. Oh, 30 millimeters. I don't know if I said millimeters or centimeters, but 30 millimeters is 3 centimeters. So we're gonna do 1, 2, 3 centimeters. And we're gonna travel round trip. So we're gonna go down and back, down and back, down and back. So we have 13 microseconds here, 13 microseconds here, 13 microseconds here, and we add them all up, and we wind up with 39 microseconds. Then the reflector is 10 millimeters away. How long does it take to get to the reflector? Still solving for time, but red flag here. How long does it take to get to the reflector? Not coming back. One-way time. One-way time. So we're still gonna set it up. 10 millimeters is 1 centimeter. And we know that if we're not coming back from the reflector, we just wanna go down to the reflector. So instead of the 13-second rule, we think of it as the 6.5, or 13 microsecond rule, we think of it as the 6.5 microsecond rule. So 6.5 to get to 1 centimeter. And that's actually our answer for this one, 6.5. We don't have to go any further. And the last one is a reflector is 3 centimeters away. How long for sound to get to the reflector? So asking us the same thing again, where it's asking us to solve for time, but one way. And now it's asking us to go 3 centimeters deep. So when we get to 1 centimeter, we will have traveled for 6.5 microseconds. When we get to 2 centimeters, we will have traveled for 6.5 more microseconds, which is 13 microseconds. And if we get to 3 centimeters, we will have traveled for 6.5 microseconds more, which is now at 19.5 microseconds that we traveled to get 3 centimeters deep with our sound without coming back to the transducer. And I will say that maybe the way I do this, the only thing that I want you to also think about is that if you're solving for the 13 microsecond rule, right? And you're thinking about time going down and back, right? We're really traveling all the way down and then all the way back. We're not doing like a bounce back, but you can think about it kind of the same way that the round trip time, right? 6.5 to get to here, 6.5 to get to there, 6.5 to get to there, then 6.5 to get back, 6.5 to get back, 6.5 to get back, right? So this part of the trip took 13 microseconds, this part of the trip took 13 microseconds, this part of the trip took 13 microseconds. If you're only going down and you don't care about returning, then you have this part of the trip took 6.5 microseconds because you're only going down. This part of the trip took 6.5, and then this part of the trip took 6.5 microseconds. So up here, to get 3 microseconds down, or 3 centimeters down and back, you would be doing 3 groups of 13, which would give you that 39. Here, if you're going one way, you're doing 3 groups of the 6.5, which puts you at half of the 39, which is the 19.5 microseconds.